Since the early beginnings in Java, we would create our data structures using getters and setters. We would declare our fields like this, and we would create our params like this. Then we would create our instances, passing on the arguments to the constructor this way. In 2009, a project made its debut to the JVM world that would revolutionize the way we create data structures. This was called Lombok, and Lombok would allow us to reduce the boilerplate code that we have been used to creating up until this time. That way, we would create getters in a different way using annotations like this. Another language was being developed at the same time, called Kotlin, and its debut was in 2016, where Kotlin introduced for the first time data classes. Data classes didn't have to use any annotation, and with them, you could create something like this, which looks much, much simpler. But Kotlin was still not as popular as it is today. So in 2020, with the release of Java 14, records were introduced. And with records, we could do exactly the same this way, just as much as in data classes. So let's go back to the traditional way of creating data structures in Java. Here we can see where we have created a getter, and here we see where we have created a setter. This is a property because we are using accessors to reach it. This is a field because we access it publicly. And these are the parameters of our constructor. Fast forward, and we can get to records and data classes. And let's look at data classes. When we look at data classes, we just don't see any of this. If we decompile this class, we can see all of these concepts implemented in this gigantic Java class, which is something we don't really see in the data class. As we don't see it in this data class, in my career, I hardly ever had bumped into so many people questioning what is a getter, what is a setter, what is a field, and what is a param. And when we see this happening is when we try to apply annotations. Frameworks like the Spring Framework usually need annotations applied to either a field or either a getter, either a setter. They have very specific places where they need to be applied. In a data class, that is not visible. And because it's not visible, lots of people have a lot of questions and a lot of trouble figuring out what is going on, why are they not behaving the way the decorator is telling them to behave. Usually the reason is just because we do need to specify in Kotlin, for example, where does this annotation needs to be applied to. So we do need to specify either a field, either a param, either a getter, either a setter, and so forth. It is one of these negative signs of a long-term effect of using Kotlin, that we forget what is a field, what is a parameter, what is a getter, what is a setter. Maybe getters and setters is a completely different discussion, but I would expect property and field not to be such a huge discussion. And it actually is. So, can Kotlin be an answer to all our problems? It can be an answer to some problems, definitely. But for other things, it might actually be a curse. So that was a dramatic ending to the first part of our video. For this part, I want to show you an example about how annotations actually work for those examples that we have seen. So in this case, for my project Spring Master Test Drives, I have this class, account lists asserts DTO. This is part of a project, and this is called size. Size is part of the Jakarta annotations package. And with Jakarta, we can decorate our data objects when we want to send data through the wire via REST services. In this case, we want to essentially validate our field according to groups. Now, groups is something different, but what's important here is to make these annotations work. As you can see right over here on the left bottom corner of the screen, we see that all tests are in the clear. If, for example, I do this and remove field from it and run the tests again, we're going to see that these tests are going to fail. Just as I expected, they fail. And if we go here down to the bottom of it, this test, what it does, it expects a bad request because we are sending data that it's not valid to be sent through the wire. But in this case, we get a 200. And the reason for that is that, of course, as we have seen before, the size annotation doesn't have a specific prefix letting it know that we need to apply this to field. But here's the catch. When we look at size, the annotation itself, we see that the target annotation that it contains thus comprises of method, field, annotation type, constructor, parameter, and type use. Important to note is that it is already stereotyped with a target of field. But unfortunately, in Kotlin, it doesn't really work that way. When we apply certain annotations, what usually happens is something different. So now let's have a look at the decompiled code. So when we decompile this code, so Kotlin bytecode, decompile, we can see an interesting thing. So the field that we want to annotate is postcode. Postcode is located here, and we already see that the field is not annotated. Because this is a final variable with val, we also are not going to generate setters. We only have getters in this case. And none of the getters is annotated with the size annotation. But we can see that the constructor has all the annotations that we need for postcode. And curiously enough, the parameter of the copy function is also annotated with size. But the crucial thing that needs to be annotated is field, and field isn't there. I can see this very clearly with the Java code, but with Kotlin, I don't see anything. So when I put field here, and let's put field on all of the three annotations. Why do I have it this way? It doesn't really matter. I have a whole video about it that explains what this group is. I put in the link in the description so that you can see a tutorial I made about it. But for now, it's important that we get our tests running again, and that I can show you why are these tests now working, why do we get them all green, and what was the change. So now let's decompile our class again. Bytecode, decompile. Exactly, so here we have the postcode. It's annotated with the three options with the size annotation. And if we look further down, we can see that in postcode now we have nothing. And obviously in copy, we don't have it as well. So the only thing that's annotated now is field. And another important aspect of this is that for this case, these Jackson annotations work really well, because for our specific case, they only need field. So that's why this works. And of course, each manufacturer or each brand has its way of using annotations. In this case, for our case, we need field. It doesn't necessarily have to be the case all the time. So now let's have a look at what happens with other annotations that don't need this. If we look at, for example, a many-to-many, many-to-many is an annotation that only has its target method and field. And this works. This works without the need to putting field on it or anything like that. And the reason for that is that if we then decompile this, we can directly see that many-to-many, along with the other annotations, is already applied to a field. In this case, receipts, and also shops. And in this case, there is no confusion. Where the confusion exists is for annotations like in the case of Jakarta, where the Kotlin compiler doesn't really know what to do with it. And so we don't see size applied to field. And these are the cases that we need to specify that we want our annotation applied to a field. And I can tell you that using field is something that is not necessarily the first thing that pops into mind when someone is used to programming in Java. And of course, the literature is filled with examples of using simply just size. And that doesn't necessarily have to be the case all the time. I'm also not saying that field in this case is the only possible fix there is, maybe with a configuration of a certain plugin or something else external. But the bottom line is, when these errors happen, it's very important for us to understand these concepts so we can find the source of the bug, understand the problem, and be able to fix it, which is the subject of this whole video. And this concludes my presentation on possible problems using Kotlin data structures for some people, of course. I've been using Kotlin already for a long time, and I cannot say that I understood this problem immediately, but it became clear after decompiling. What didn't become clear, of course, is what I said already in the video, that so many questions came up when trying to explain the source of the problem and the fix. Alright, so this wraps up our video. I hope this video made a difference to you. I hope that you were able to learn something with it and that you can use this in your future career, whether it is in Kotlin, Java, or any other language. I think it's important never to forget what a field, what a parameter is, what a property, and especially what an argument and a parameter is. These concepts are important to know. And if you enjoyed this video, don't forget to leave a like, the usual. Don't forget to subscribe. If you dislike this video, please give me your dislike. And if you are interested and want to give an input, I will be very happy to hear your comment in the comment section. Find out the links to these projects, especially the Spring Master Test-Rise project with these examples that I just showed you, in the description. And if after watching this video you are still interested in learning about Kotlin, don't forget to watch the playlist I made with only Kotlin videos right over here. As a short disclaimer, I'd like to mention that I'm not associated or affiliated with any of the brands eventually shown, displayed, or mentioned in this video.